As we have seen, these are used to characterize the behavior of a sensor when it is being subjected to a stimulus or input signal. These are time dependent characteristics set with reference to a period. That means the period is that between the time of application of a stimulus or the input signal and the time that the sensor reaches its steady state. In this session, we are discussing about few dynamic characteristics such as speed of response, fidelity, measuring lag, dynamic error, etc. Speed of response. It is defined as the speed with which an instrument responds to a change in the value of quantity being measured. Say if an input is given at a particular moment and at how quick it is responding to the input signal, it is called as the speed of response. Again, another term is response time. That means it is a time taken by the instrument to reach its stable value from 0 once the stimulus is applied. In this diagram, we can see that, say, this is the output shown and this is the output that we expect. That's a stable value. This is a stable value. So the time taken by the instrument once the input is already given, so it takes this much of time to reach the stable value, and that time is called as the response time. Fidelity is another term. It is the degree of closeness with which the system indicates or records the signal which is applied on it. It also refers to the ability of a system to reproduce the output in the same form as the input. I will explain this. Degree of closeness to which the system indicates or records the signal. That means a particular signal, say you take the case of a microphone, you are giving a sound, that is a signal that is given. Are you sure that the microphone is picking the same signal as such, or is it losing something? If it is capable of recording the same output as such, it is a high fidelity instrument. Again, in this, take the case of a CD player where there is a CD. In that CD, some song, your favorite songs are there. Now, if you play the CD, even the highest quality, if it is copied in the CD, or whether your instrument is capable of picking the same instrument, the value that is stored and give an output. That means if the system is capable of reproducing the output in the same form as it is available, then it is a high fidelity instrument. We have heard this hi-fi term connected with our music systems. That means a system, if it is capable of picking the input signal and copying it as such, or if it is capable of reproducing the existing output signal as such, then it is called as high fidelity instrument, hi-fi device. Another dynamic characteristic is measuring lag. Lag, as you know, it is a delay. Lag means delay of an instrument to respond to the change in input signal in real time. Real time means when instrument is actually subjected to an input signal and how much delay it is taking to respond to that. That is called as measuring lag. We have two kinds of lag typically represented in connection with transducers. One is the retardation type of lag, that is the measurement system instantaneously begins to respond only after the change in the instrument have occurred. Okay. Now there is another kind of lag called as time delay type of lag, where the measuring system begins to respond after a dead time to the applied input. Dead time means it is a time required by the instrument to begin its response to a change in the quantity to be measured. Another term is dynamic error. It is the difference between true value of instrument, the parameter, and the output given by the instrument with time during the measurement process itself. I will give an example. You might have done force measurement in lathe, cutting force measurement, and you are using dynamometer to measure the force. Now, during the machining process itself, the force applied on the tip of, or the force experienced by the tip of the cutting tool will be it is expected to be shown in the monitor or the device, but are you sure that is it showing the same value on the display which is actually available at that time at the tip of the cutting tool? It can be different. That means even if there is a force happening at a particular moment, the output given may be little away from the actual instant. So the difference between the true value and the output that is shown, it is is called as a dynamic error, the error between the actual value and the true value again, but in the dynamic situation. So if this is the actual kind of behavior of the input, and what is measured is this is actually a better situation where it is actually picking up the same output, though there is a little delay. So there is an error. If you take the case at any moment, there is an error here, there is an error there is an error. So this is called as dynamic error. So this dynamic error need not be equal or almost uniform like this. There can be difference between output and input, the actual value and the measured value during the measuring process itself. The speed of response and fidelity that we have seen in the previous slide are desirable characteristics, whereas measuring lag and dynamic error are undesirable characteristics. Overshoot is another characteristic. That means due to inertia of moving parts or some special reasons, the pointer of an instrument may not come to steady position immediately. You might have seen this in voltmeter. That is, when the voltmeter is connected to a circuit, the pointer will oscillate like this first, then come to a rest. That means the oscillation is like this, and finally it will be coming to rest, and this is the mean point that is required. So there is an overshooting happens, and finally it will be stabilizing to the required position. So that is called as overshoot.